Alright, I wanted to record a video about memorizing the basal ganglia and their associated pathway and disorders. So if we look at first aid, this is basically all that I'm going to explain. It looks like there's really not a lot, but in truth, this together can be somewhat confusing. So I just wanted to reiterate the information in a way that makes more logical sense. Okay, so the first thing is, what is the basal ganglia even involved in? Well, the basal ganglia is involved in controlling planned and coordinated motor movement. So let's just type that in. Okay, let's make that bigger. All right, so the major structures that are going to be involved in this basal ganglia, respective to what we have known, are going to be the putamen, the caudate, and the globus pallidus. Okay, the first thing that you should know is that these three structures can be grouped, and I'm telling you right now, this is going to help you memorize the indirect and direct pathway. So you'll get two groups. The first one is called the striatum, and the second one is called the lentiform nucleus. So here we have striatum, and the second is called the lentiform nucleus. I'm just going to abbreviate nucleus like this. If I were to write this, that's nerve, and this is nucleus. And apologies for the bad writing. I am writing with a mouse, so it's not going to be super neat. Okay, so what should we know about the striatum? Well, the striatum is made of two structures, and the lentiform nucleus is also made of two structures. They actually have something in common. It's going to be the putamen. And you should definitely know that, and it will help make the indirect and direct pathways make more sense. What they have different is that the striatum is going to be the caudate, and the lentiform is going to have the globus pallidus. Okay, now that we have this out of the way, it's going to make a lot more sense as to how we memorize the direct and indirect pathways. Direct and the indirect pathway. And both of these are going to be involved in motion. The direct is going to cause the stimulation of motion, and the indirect is going to cause inhibition of the motion. So to memorize these, it's really simple. The direct has really 5 paths or 5 steps, and the indirect has 7 steps. You should know that these guys are also going to share some steps. So the first thing that I want you to know is, how do we even cause the starting of this pathway? Well, that would be from the cerebral cortex, or specifically the motor cortex. Okay, the best analogy that will help you remember all of this is, I want you to think of this whole system as like a car engine. Okay, that is not what a car engine looks like. But you see how there's an input and an output? When you're starting your car, you need to put the key in the ignition and like ignite the engine, right? So your motor cortex is going to be your initiating signal. This is important because if you're causing an initiation signal on either of these pathways, they both will be mediated or initiated the same way. So the motor cortex will cause both direct and indirect, but useful in different situations. Okay, well, how does it even initiate it? So since this is an excitatory signal, uh, the mediator or the second messenger or neurotransmitter, whatever you want to call it, that's going to be glutamine. And it's important to know glutamine because glutamine will show up in a couple other steps and its opposite will show up in other steps. And if as long as you're following the analogy, it will make perfect sense. Okay, so as we stated, the first step was the motor cortex, and this is when we stick the key in the ignition. And as we're starting the process of returning our key in the ignition, we're starting up the engine, right? So this is an excitatory signal, and that's going to cause either direct or indirect. Okay, so now we're going to talk about the next step. We stuck the key in the ignition, and then we need to turn the key. You know how like when you stick your key in the engine, you go 1, 2, 3, and then boom, the engine like starts igniting. There's a little bit more than that, but for now, just remember that part. Okay, so that's gonna make the second thing that we stimulate, the striatum. And I'm gonna actually take my eraser here and remove this section in between, because this is also a shared step between the direct and indirect. You first start the excitatory signal, and then to balance that out, you send an inhibitory signal. And remember how I said glutamine will show up and its opposite will show up? So if this is an excitatory signal, this is going to be an inhibitory signal. And the inhibitory signals are going to come via GABA. Okay. I also said, by the way, earlier on, that if you remember the structure of the basal ganglia that we talk about, it's going to make perfect sense, right? And I talked about the caudate. I talked about the putamen. And I also talked about the globus pallidum. And I said that these guys are grouped, and I also said that these guys are grouped. Okay, so this part should make perfect sense. So if we said that this is the order and caudate and putamen are grouped, once we send our signal through the engine, we're actually going to go through the first part. So this whole thing together is called the striatum, right? So that's actually how you remember that the second step is striatum, because we're going through the steps. Like you stick the key in the engine, you turn it 1, 2, 3, and then you let it go and the engine starts. So if this is the first and second steps of turning the key, we're going through the caudate and the putamen, because 1, 2, 3. Okay, so now that we started and we talked about the striatum, and this is through GABA, and I told you that the striatum is through direct and indirect, well, now we're going to start having our steps that are unique to the different pathways. Okay, so I'm going to draw a line here, and then I'm going to continue this downwards to about here. Okay, so now here is where the paths differentiate. If we're on the third step and we went through the striatum, right, and the striatum has caudate and putamen, then we need to go through the third step. So we're going to talk about putamen and globus pallidum. Well, the putamen and the globus pallidum, these two together are the lentiform nucleus, right? Lentiform nucleus. Okay, well, if we're going through sticking the key in the engine, it's 1, 2, 3. It's not 1, 2, 2, 3, right? So we already did caudate and putamen. So that means the third step has to be talking about the globus pallidum. Great. So this step right here is going to be talking about the globus pallidum. And I'm just going to abbreviate it here. Okay, but there's an important difference, right? Like here we're on the direct pathway, but here we're on the indirect pathway. So if we're talking about direct pathway and we're stimulating motion, this is going to cause an excitatory signal because we want stuff to happen, right? So on this side is going to be excitatory. This side is going to be inhibitory because we want to stop motion. Okay, but now there's something kind of important. I put globus palladium on both sides, but it's not the actual entire structure on both sides. So interestingly enough, the globus palladium has this outer structure and it also has an internal structure. And the pathways do different things based off where in this structure that you are. So that's the key difference here. If we're talking about the direct pathway and we want excitatory impulses, we're going to be talking about the globus palladium internal structure. Okay, I know what you're thinking. I just told you this is excitatory, so shouldn't this be globus palladium externus? Unfortunately, this whole pathway is kind of like a double negative or a triple negative, depending on how you see it. So we have to actually do inhibition of the internal structure of the globus palladium. So let's write that out. This is a good color. Inhibition. Okay, so that means the third step in the direct pathway is the inhibition of the globus palladium internus. Okay, I know this is probably starting to get a lot, but trust me, this is the simplest way to go about it, and it's actually just going to make the next step very simple. So if you're talking about the globus palladium internal structure, this is actually the thing that's going to talk to our thalamus. So if we have our globus palladium here, it's going to send the signal out to the thalamus. And note specifically where I drew this arrow. I didn't draw it out here or out here. I drew it in the center. And that's going to be a key point that we're going to touch on. So as I just said, we inhibited the internal structure of the globus palladium. So that means we get to straight up talk to the thalamus. Okay, and if we're talking to the thalamus and our goal is to start movement, is there not a structure in the thalamus that will project to the primary motor cortex? Well, yeah, there actually is. If you watched the previous video that I made about the thalamic nuclei, you're probably familiar with this drawing, right? And I told you that there's 4 rectangles down here, and there's an anterior group and a posterior group, and if we drew the line upwards, we would basically figure out exactly what our function is. So if this is where the central gyrus is and we projected directly up, right, you can see, maybe I should zoom in. So you can see this part in front of the central gyrus is the precentral gyrus, or the primary motor cortex. So if we're projecting the primary motor cortex and then we're talking to the cortical region responsible for movement, then all we need to do is just figure out, like, well, where in the thalamus are we? Okay, and if you watched the video that I made, you would actually know that the part of the thalamus that we're talking about, let me choose a good color here, is going to be the ventral lateral part, the VL, because there's a ventral anterior and a ventral lateral. And ventral anterior is more like proximal limb structures, maybe more upper, but VL is going to be your group for talking about movements as the signals go through the thalamus. Okay, well then that kind of just makes our job easier, because if we have the stimulation of the ventral lateral group of the thalamus, we get motion. Okay, well, great. That's exactly the goal of the direct pathway. So it's really, really simple. Remember, the first thing that you do is you stick your key into the ignition. So we're starting the excitatory impulse. So the motor cortex is going to send the signal, and we're going to get glutamine. Glutamine is going to start the direct pathway, And then we're going to go through our three major basal ganglia structure: the caudate, the putamen, and the globus pallidum. Since we did an excitatory impulse, we had to follow up with an inhibitory impulse. So this is GABA. And if we went through striatum, which is the caudate and the putamen, and we turn our, this is the part where we turned our key in the ignition to 1, 2, and then you need to push it one more further into 3 to start the actual ignition, right? So 3 is going to be where your globus pallidum internal structure is. Well, specifically globus pallidum, but internal is what we're referring to in the direct pathway. Okay, so that's step 1, 2, and we're starting at 3. If we're talking about the globus pallidum and we have the direct pathway, we need to send the double negative, or the inhibitory signal, to the internal structure. And remember how I drew this drawing here? Well, if this is the internal structure, and I told you the internal structure is what talks to the thalamus, the moment we're at the GPI, or the globus pallidum internus, we get to talk to the thalamus. And if you remember my drawing from before, we're at the ventral lateral part of the thalamus, which is going to project to the precentral gyrus, which is going to allow us to do motion. So there you go, 5 steps. Okay, now we're done with the direct. Let's do the indirect pathway. The indirect pathway has the same 2 steps as a direct pathway. You're going to have initiation from the motor cortices, then you're going to have excitation through the striatum, and then the striatum is going to send this inhibitory signal through GABA, and then we're going to talk to our globus pallidum. And remember how I told you this is a double negative system? Well, the indirect pathway will actually talk to the external part of the globus pallidum. Okay, so you can see here, there's actually a pretty important difference between the direct and the indirect. They might both start by talking to the globus pallidum, but this is going to talk about the internal part of the globus pallidum, and this is going to talk about the external part of the globus pallidum. And remember how I drew this drawing over here, and I said the internal part of the globus pallidum is going to talk to the thalamus, and I did not draw an arrow over here, right? So let's just draw some X's, right? There's no signaling from the GPE to the thalamus. So that means if we're at the GPE, or globus pallidum externus, we don't get to talk to the thalamus, which means we somehow need to make our way to the GPI. So that's how you remember that there's another step. If we're talking at the globus pallidum externus, we're actually going to talk to the subthalamic nucleus next. Okay. In the constitutional state, the globus pallidum externus is providing signals onto the subthalamic nucleus, and perhaps I should write that out. Subthalamic nucleus. Okay. So the globus pallidum externus is going to talk with the subthalamic nucleus. And remember how up here we have the inhibitory signal, right? And which is going to cause an inhibition on the GPE. So let's just write that in. Inhibit. Normally, GPE causes an inhibitory signal on the subthalamic nucleus. And that's when the indirect pathway is not called upon, nor the direct pathway is called upon. So it's a constitutively active inhibition of the subthalamic nucleus from the globus pallidum externus. But now, since we're turning our key in that engine, we're actually calling upon the functionality of GPE. But we've just inhibited the GPE, right? And remember how I told you here we have a double negative? Well, we're going to have another double negative here. This is our double negative step. So the inhibition of GPE is going to cause the inhibition of the constitutively active inhibition of the subthalamic nucleus. So what is that going to net us? That's going to net us an excitation. An excitation of the subthalamic nucleus. Okay, now that we've excited the subthalamic nucleus, now we can actually talk with our globus pallidum internal structure. Oops, let me just fix that. Okay, so because we excited the subthalamic nucleus, which otherwise would be having inhibitory signaling, now we can interact with the GPI. And remember how the direct and indirect pathways are oppositional to each other? Well, yeah, that's kind of what's going to happen here. If before, on this side, we inhibited the GPI, well, now we get to excite the GPI. And if the GPE would have caused excitation, and now we're on the GPI, which is indirect pathway or inhibition of motion. And I told you here on this drawing of the globus pallidum, let's actually just put that in here. Only the internal structure of the globus pallidum can talk with the thalamus. Well, guess where we are? We're at the globus pallidum internal structure. So that means our next step is going to be talking to the thalamus. Okay, and what part of the thalamus are we talking with? Well, as we determined on this side using this drawing, using the previous video about the thalamic nuclei and how to remember their functions, we're talking about the ventral lateral group of the thalamus. Okay, and if here we send the inhibitory signal, and now we're sending the excitatory signal, that's going to cause a decrease in motion. And there you go. That is direct and indirect pathways and how you can remember them. Again, let's try to make sure we keep that key engine analogy in mind, and it will make it so much easier as you go through it. In this section of the video, I want to talk about the disorders associated with the basal ganglia. So there are three major disorders that we're responsible for knowing. That would be Parkinson's, Huntington's, and hemibolismus. I will go through what the presentation of all of these three are, but I also wanted to include this, smaller version of the indirect and direct pathways, because I think it will make a lot of sense as to why the presentations present the way they do if you know how it relates to the pathways. So let me just fix this really quick. Because again, GPI talks with the thalamus, and GPE is going to talk with subthalamic nucleus. All right. So we're talking about the disorders. The first disorder that you need to know is Parkinson's. And I'm going to put Parkinson's right here, and that will make sense in a second. So what is Parkinson's disorder? Parkinson's disorder is a disorder related to the basal ganglia, and it has a somewhat confusing presentation. You get bradykinesia, which is slow movement, but then you also get rigidity and loss of postural reflexes, and also a pill rolling tremor. And you might think, well, how is this supposed to make sense? If you have slow movement and also a pill rolling tremor, aren't these kinds of opposite? And I'm glad that we're making this point, because I'm about to show you why that happens. So this is a little bit out of the scope of what you generally need to know, but there is a type of neuron that I'm going to draw looking kind of funny. And I drew it in a specific way, not just because of like the dendrites and all that, but because the name of this neuron is called the medium spiny neuron. Okay, it's a little too big. Let's change that. All right, a little too small. right? And again, it's not that important, but it's kind of helpful to know. So this medium spiny neuron has something called a D1 receptor, and it also has a D2 receptor. And these two are mediated by dopamine. Okay, so D1 is a receptor that's involved in the direct pathway, and D2 is responsible for the indirect pathway. And both of these together are related through dopamine. Well, how do we get dopamine? We get dopamine through the substantia nigra. You could also probably say some of the ventral tegmental areas, but for now, let's just stick with dopamine. So let's draw a quick brainstem section. And if here we have our cortical tracts, you will get a section bilaterally that is kind of darker from the rest. And it's usually because it's stained with melatonin. So these sections will be a little bit darker as compared to the other structures at the same level. And quick homework, what section is this? Anyways, so this is the substantia nigra. And the substantia nigra, as previously mentioned, is responsible for dopamine circulation. And in Parkinson's, you have a disorder within the substantia nigra or any of the other pathways that are responsible for dopamine. And so if the substantia nigra is going to create dopamine, then you get a disorder in both the direct and the indirect pathway. So knowing this is actually going to help you so much because that explains why you get both the bradykinesia and you also get the pill rolling tremor. Pill rolling tremor. Because when you have the disruption of the D1 receptor into the direct pathway, you get bradykinesia because the direct is supposed to give us movement. But bradykinesia is a presentation of Parkinson's, which is slow movement, is going to happen because you have an inability to recruit the direct pathway. In the same way, you get the pill rolling tremor presentation because you have an inability to affect the indirect pathway. And if the indirect pathway is supposed to stop movement, well, we're not able to stop these fasciculation or tremor-like motions. So that's why in Parkinson's you get both of these. All right, the second disorder that we need to know about is called Huntington's. I'm just going to abbreviate like that. Okay, so what is Huntington's? Huntington's disease is a disorder that affects striatal regions like the caudate nucleus and the putamen, and although it's generally considered to be excitatory, it has progressive atrophy that's associated with hyperkinesia. And I'm going to put the symptoms over on this side because I will need this space. So we're going to call this hyperkinesia. And hyperkinesia is excessive movement, right? So why are we even getting Huntington's disease presentations? Well, remember how I said Huntington's disease primarily affects the striatal regions? Is that not this step right here? Yeah, actually it is, and you would be totally right to assume that. So Huntington's disease is a disorder that affects the striatal regions. And what's within the striatum? Well, that's going to be our putamen plus our caudate. Because remember, this is where we insert the key into the ignition, and this is 1 and 2 before you push into 3 to even start the ignition of our engine. So Huntington's disease is a disorder that affects the striatum, or the putamen and the caudate. And Huntington's disorder or disease is going to present with hyperkinesia, chorea, and atheosis. So again, if you're affecting the striatum, which is responsible for both the direct and the indirect pathway, then that explains why in Huntington's disease you get both chorea and atheosis and hyperkinesia, which are seemingly opposite presentations, but there's actually a specific reason as to why that is. Okay, now the third disorder that we need to know is hemibolismus. Okay, hemibolismus is another disorder that affects the basal ganglia pathway. So hemibolismus, as you can see, it's hemi, it affects contralateral limbs, and it's associated with focal subthalamic nucleus lesions. So hemibolismus is actually a disorder of this section right here in between. And now you're thinking, well, you just told me subthalamic nucleus. Well, why are you drawing it here? Well, remember how I said constitutively active, or rather, the globus pallidum externus has constitutively activity of inhibition of the subthalamic nucleus. And in here, we're supposed to cause the inhibition of the globus pallidum externus, which is going to cause the excitation of the subthalamic nucleus. But we don't have that. So this step right here between the two is actually what's being affected. So hemibolismus is then going to present with, it has a pathophysiology that occurs due to inflammation or vasculitis of perforators, and which go to the subthalamic nucleus, and it's also associated with toxoplasmosis in immunocompromised patients. So let's just write that out. It's associated with inflammation to the STN or toxoplasmosis in immune compromised patients. Okay, so these three together are the major disorders of the basal ganglia nuclei.